So this lecture is on evolution, and I think it's really important to understand the theory of natural selection, how it plays a role in evolution, in the changing of organisms. I think there's a lot that is misunderstood about the theory of natural selection, so I want to go through that with some detail. I also want to make the point that our own natural history, our evolution, the pressures that were placed on us and our ancestors tell us a great deal about many aspects of what motivates behavior, from the food we eat to sex to aggression to fear. These are all in our brain and are there for a reason, and even in a modern society they play a very major role. So let's talk about evolution and go through Lamarckian theory, go through Darwinian theory, and provide a little bit of evidence. I think it's important for you to get this lecture in many different classes you have in college. So, the great moments in evolution. I love this cartoon. So let's go through some theories that started, because really, even before Darwin, people had ideas that the organisms that were on the earth then were not the organisms that were always there, that they had changed. It was really Darwin that came up with the good theory. So philosophers, scientists, for a very long time knew that this was happening. It was the theoretical mechanism that was unclear. Even people like Aristotle, Linnaeus, they wrote about this possibility. Well, let's go through Lamarck. Lamarck has had a bit of a resurgence lately, but Lamarck was before the time of Darwin, but not by much. And he said that animals progressed, that they modified within their own lifetime to adapt within their own lifetime to the pressures that they faced, and then they passed on those adaptations. So organisms offspring inherited the acquired characteristics of their parents. So here's the very famous Lamarckian giraffe idea. The giraffe is stretching its neck, pulling its neck to get the leaves at the top of the tree. Through its life, its neck gets longer. That individual's life, the neck gets longer, and then its offspring have longer necks. Okay, so here's two people, and they grow big muscles during their lifetime, and of course their babies look, well, okay, maybe not like that, but that was the idea. In fact, Lamarck even talked about somebody who was a blacksmith who had a very strong bicep. His kids would have strong biceps. But this is really not how evolution takes place, although there is some evidence that the pressures we faced in our own lifetime can have effect on our offspring, just not to the level that Lamarck talked about. So animals and plants do not pass on acquired characteristics typically. Can you think of something that we do pass on from generation to generation that we acquired during our own lifetime? Well, we pass on our laws, we pass on our culture, our ideas, our views. So in a way, especially humans have Lamarckian characteristics. We have things that we do pass on. It's just we pass them on socially. Doesn't mean they don't change a great deal from generation to generation, and it doesn't mean that they aren't highly influential on people. So our culture is really Lamarckian, but we're going to talk about physical characteristics, especially physical characteristics, and think about the brain. So we'll start with Charles Darwin, and he was a naturalist. Now, it's a great story. He has a great story because he came from a rather aristocratic family. In other words, they had a lot of money. And if you come from that kind of family, then you go and you become a doctor or you become a lawyer or something like this. And so he went into medicine, but he didn't really have a stomach for it because medicine back there was pretty gruesome. But he loved nature. He loved the outdoors. And he got the opportunity to travel around on a ship for 5 years, the Beagle, the HMS Beagle. not really as the naturalist, but mostly as a companion for the captain, a guy named Fitzroy. And because the captain couldn't really fraternize with the help, but they could with somebody aristocratic like Darwin. But Darwin and Fitzroy really didn't get along very well. But Darwin loved to travel and get off the boat and look at everything he saw on all the places that he stopped, especially in South America. You know, there's a funny story that Charles Darwin said that he got so seasick that any opportunity he got to get off the boat and stay off the boat, he did for a long time. But he also read a lot, and he read some books that were very influential in his theory. One of them was the Thomas Malthus book, and this book was about reproduction and over-reproduction. And Malthus talked about the geometric growth of organisms that are kept unchecked. In other words, all organisms produce more offspring than the environment can handle, and yet populations tend to stay in pretty consistent numbers. In other words, not all organisms that are born or hatched or grown can reproduce, and that was really important to Darwin's theory. He also read books, a guy named Lyell, on geology, and people began to understand by looking at geology that the world probably wasn't 6,000 years old, as the Bible had said. It was probably millions of years old, millions and millions of years old. That gave Darwin the idea that there could be time for things to change. So from these ideas and from his observations, his tons of observations, he came to the conclusion that animals and plants and organisms could change over time. And so he came up with the theory of natural selection. So we really don't talk about the theory of evolution. We know evolution occurred. We talk about the theory of how it occurred. Remember, theories are not whims. Theories are well-supported ideas of how things work. And the theory of natural selection is probably one of the most, and the theory of natural selection is probably one of the theories in science that has the greatest amount of evidence. So I'd like you to know the theory. And it gets a little bit complex in its detail, but really in its idea it's rather simple. It comes up with 5 postulates, 5 ideas, 5 observations. The first, and this comes from Malthus, is all organisms produce more offspring than can survive to reproduce. So, like, if every bunny that had bunnies, if all their offspring had offspring and all their offspring would have offspring, we would be knee-deep in rabbits in a really short amount of time. But that's not true. Let's say rabbits have 10 little bunnies. Only a couple of them maybe can reproduce. The other become food or die. Here's the second postulate. All organisms show variation within their population. A population is, by definition, a group of interbreeding members of the same species. A population of squirrels, a population of bunnies, a population of trees, of certain trees. But within that population, there's variation. There's different colors, different patterns, different sizes, different resistance to disease, a different taste in mates, different mental abilities. Look at the population of human beings. We're all different. We all have different characteristics. Certainly we have a lot of similarities, but there is some variation. The third postulate is that those that reproduce have to compete for that. There's competition among members of a population, competition for food, for space, for mates. There is competition within species for survival. So the fourth postulate is those that happen to be able to compete more successfully at that time, whatever the environment is giving to that animal, is constraining on that animal. Those animals that run faster, that hide better, that swim faster, that are more resistant to a disease, that have a different color, have a pretty feather, whatever it is that helps them survive at that time and helps them to breed at that time, they on average have more offspring. Okay? So they live longer, they produce more offspring, and nature selects which of those animals compete better. As the environment changes and applies different pressures, and this is key, the world changes, the environment changes, the pressures change, then organisms modify from generation to generation, not within their own lifetime and pass that on, but through descent, through generation after generation. I'm going to give you a bunch of examples of this. So, we know that there are a lot of changes. Let's just think of a few. Let's think of weather changes. Let's say a bunch of squirrels, I'm going to keep with the squirrel theme here. A bunch of squirrels are living, everything is fine, and one animal tends to climb faster, and there's a flood. Well, that attribute that it has, that genetic attribute it has for climbing, is passed on. The other ones don't. Let's say it gets hotter, and the one that climbs faster has more fur, or let's say, and it dies, but a one that has a little less fur and can regulate its temperature better, than it survives. And we know that the world changes. Continents have shifted over millions of years. Hurricanes come through, weather events come through. The earth gets hotter, the earth gets colder. Right now the earth is getting hotter, putting a great deal of constraints on organisms. Think of the pressures that humans place on other organisms. Okay? So there are a lot of environmental pressures. I mean, what's global warming going to do to animals? Those animals that regulate their temperature better, those animals that can handle fluctuations in temperature better, they are the ones that are going to survive. They have genes that help them do that. They will pass on those genes. But there's also pressures behaviorally. Migration and predation and tool use and all these kinds of things. And those affect the genetics that regulate behavior, regulate the brain. So the brain changes. There is mate selections. And this isn't always about the health of the population. It's about the health and survival of the individual. So, you know, there are animals with these big giant antlers, right? Look at this elk. Well, that might not be the easiest thing to carry around. It takes a lot of energy. But it helps it survive better. It helps it compete with other animals by other males by rutting against them. These animals have different colors that might make them brighter and more susceptible to predation, being attacked and eaten. But it's brighter and they helps them get mates better. Now, when we talk about evolution, we often talk about microevolution and macro. Macro are big big structural changes that happen over millions of years. But we can also look at small changes. And one of the examples that's often given is the pepper moth as an example of micro changes in evolution. So here we have a moth that has variation within a population, variation. Some of these moths, and they interbreed, some of them are rather dark, and another variation is a pepper. I bet you didn't see this moth. Well, because it's camouflaged against this aspen tree. So if birds are coming along and picking off these moths and eating them, who gets picked off? Well, this one does, the black one. So its genes for black color isn't passed on as easily as this one. So there are a lot more of this one than that one. Now, suppose, as happened in the early part of the 19th century, you had a lot of soot in the area, the Industrial Revolution, and all of a sudden in these trees it's getting a lot of soot from a coal-fired plant. Well, now who is surviving better? Okay, this pepper moth only a few generations ago were laughing at this black one. You know, look at me, I'm hiding, but now the black one does. And so people tracked this and looked at this microevolution, which was simply the increase in the genes that made a black moth. So while there was a lot of white moths compared to black for a very long time, over the course of a very short time, by natural selection, by birds picking off the white one and leaving the black one, over the course of 10, 20 years, suddenly there's a lot of black ones. That's a micro change, a microevolution. I sometimes think of this as an example. Now, these are all different species, but this helps me sometimes picture natural selection. Let's take up a seagull. Here's a seagull. It's flying around. It's all good. And let's say it's a bird and it likes to fly. It has big feathers. But let's say in its area it gets colder, or it migrates north and it gets colder. Well, these big, long wings and feathers get frozen. But there's variation. There's some of them that have slightly smaller feathers. Some of them have a little bit more fat deposit. And over generation of breeding and dying and generations of breeding and dying, those that have shorter wings and a little bit more fat deposit tend to, on average, breed more and survive more. So you might have birds eventually that are similar to this bird. A little bit shorter wingspan, can handle a little bit more cold, and maybe these animals find themselves in colder and colder environments generation after generation, hundreds of years. And maybe you end up with a puffin. Okay, now here's a puffin. It still has wings, it still can fly, but it's got a lot of fat deposit, a lot of insulation, short beaks. It can handle the cold a lot better. So these types of birds survive better in the cold. But let's say these migrate even farther north, and let's say it gets even colder, and a lot of them die off. But some of them, because there's variation within the population, have a little bit more fat, a little bit smaller wings, can dive a little deeper into the ocean, can handle the cold, and then we get animals that are birds, but are penguins. They don't fly. They got a lot of fat deposit. They're much better at swimming. Okay? These are the pressures placed upon the animal. Now, Darwin presented a lot of evidence. Even in his time, he was a stickler about collecting evidence, and he wrote a lot of books. He wrote books about barnacles and books about plants and all these things, and he wanted to provide a lot of evidence. And he actually wrote his theory down while he was on the Beagle. He collected a lot of data for that, but he actually waited 25 years after returning to present his idea because he knew it would be very controversial, and it needed a lot of evidence. Now here's another piece of evidence, and there's a lot of it, but this is the one that he talked about. And these are homologies. Homologies, homo means same, homologous structures. Homologous structures of, let's say, the arm. Well, let's look at a human arm, okay? It's got the humerus, the radius, the ulna, and the phalanges down here. And it has a certain function. But a lion who doesn't have the same function as a human arm has the humerus, the radius, the ulnus, and the phalanges. Same with a horse. Even a whale. A whale's front flipper and a human's front arm have extremely different functions. But here's a whale. It has the humerus, the radius, the ulnus, and the phalanges. And he said, well, look at all these structures. They probably had common ancestors that when placed under different pressures evolved over generations and met the pressures of their environment. Even a bat wing has humerus, radius, ulnus, and phalanges. Okay? So common homologous structures talk about and reflect on common ancestors. Another one is known as ontogeny. Ontogeny recapitulates phylogeny. Okay, you don't have to write that down, but it's one of my favorite phrases from natural selection. Ontogeny is our own personal development, our own individual development. From the time we're a tiny little zygote to the time we mature. That's our ontogeny. Recapitulates or goes through the same process as our phylogeny. Our phylogeny is our ancestral natural history, our evolution. Ontogeny looks like our evolution, right? Ontogeny recapitulates phylogeny. So if you look at embryos, and this is kind of over-exaggerated, but there was a time in your development, maybe when you were very, very, very tiny, 3-week-old little embryo, where you had gill slits and you had a tail, and you looked very similar to the development of a lot of other organisms. You began to change. You began to develop as other animals did. And so our evolution, in some ways, looks like the evolution of our species. And we have very similar embryological development to our ancestors. Another piece of evidence that Darwin wrote a lot about, because he traveled around all these islands, is what is known as island biogeography or biogeography. And that is the distribution of animals and the animals filling different niches, different areas that had different requirements. For example, the finch, right? The Darwinian finch. He found all these finches on different islands around the Galapagos. And he looked at the tremendous similarities in all of them. He collected a lot of them. And this one up here ate big, thick nuts. And this one over here actually poked stuff into holes to get at insects. And this one ate insects because it had a very tiny beak. And this one ate seeds. And this one ate big, thick seeds. And he looked at this radiation from common ancestors to meet the niche, the environmental pressures. And they were very, very similar, but they had changed only slightly in and around these islands. Island biogeography tells us a lot about the theory of natural selection. But Darwin also wrote about artificial selection. He knew we could do it. He knew we could change animals. He knew that nature could change animals. And so he talked about artificial selection because we had been doing artificial selection for a long time. Artificial selection is a matter of having animals as humans, picking the ones that have the characteristics that we want and causing them to breed. So we create all these different breeds of dogs. All these different breeds of dogs by selecting some. We want some with longer hair around their head, so we take those puppies that have that and we breed them and breed them and breed them. We want big giant ones that can handle cold, so each member of the litter that's bigger and bigger, we breed those. And we can make animals that are very, very different. And we get into what's known as a speciation. Speciation is the idea. Well, let's define species. A species are animals or plants that can and typically do interbreed. That's a species. Okay? So let's take a dog. That's Canis familiaris. Familiaris is the family dog. That's the species. Canis is the genus. Canis familiaris. But there's also Canis lupus. That's the wolf. Canis, the same genus. Lupus, different species. Now, dogs and wolves can interbreed. They just don't do it naturally or often. Okay? So, species is kind of a fine line. But what's funny is these two animals you see here are the same species. although they probably shouldn't be. These are both Canis familiaris, Great Dane and a Chihuahua. Okay? These two animals don't typically interbreed, especially if this is the male and this is the female. Okay, I just gave you a mental image, and I apologize about that. But there's a point at which animals stop breeding with each other, and we get a speciation, a change enough. And that can be because they breed at different times of the year, or they are geographically isolated, they are not around each other anymore, all these reasons. And it might be they might be separated for so long that even if they did get back together, they couldn't interbreed because their genes don't intermix well. So that's a speciation, okay? And so we can look at coming back to artificial selection. We've artificially selected corn and poultry and cats, and we know that we can do this, and we can modify animals considerably. Why can't nature do it? Why can't nature select? It just needs more time, okay? So we have all these different breeds of cattle that have different qualities of meat or milk or whatever. Okay, so coming back a little bit of history, Darwin wrote on Origins of the Species, which talked about his theory of natural selection. And then he went on to write other books. And these books dealt with the descendant of man. He didn't really write a lot about man in his first book, but he said, well, there's ways of looking at natural selection and thinking about human beings evolving as well. And he talked about the mental life and mental evolution of animals. He talked about this in a book called The Descent of Man. He was looking for mental continuity, homologous mental capabilities to add support to his theory of natural selection. We have homologous arm bones. Why don't we have homologous mental characteristics? Do animals have similar or same mental capabilities? And he used a lot of anecdotes. And a guy named George Romanes, he wrote a book called On Animal Intelligence that really came from Darwin's idea. These were a lot of anecdotes. This is known as the anecdotalist period of animal intelligence, where he wrote stories about the cleverness of cats and even animals that show racism. Humans are racist, so ants are racist too. And it was trying to get at the notion that we aren't separated from other animals, even at the mental capabilities. Man, with all his noble qualities, with sympathy that feels for the most debased, with benevolence which extend not only to other men but to the humblest of living creatures, with his godlike intellect which has penetrated into the movement and constitutions of the solar system, with all these exalted powers, still bears in his bodily frame the indelible stamp of his lower origin. He was looking and saying, not only are our structures similar to other organisms, but everything about us have similarities, even our mental capabilities. The Descent of Man is really actually a really good book to read, really interesting. Others took on this idea, and this comes to this class in motivation. And so other people that were really champions of Darwin, a guy named Herbert Spencer, for example, he coined the term evolution. That wasn't Darwin. He coined the term survival of the fittest. He also coined the term social Darwinism, which is a really kind of nasty part of our history. I'll talk about that in a second. Spencer said, one would expect sensitivity to pleasure and pain and their relationship to motivations, suspense, would also show variation within a population, therefore become a selecting agent. Something to select for. And this led to kind of a dark time, a time we call eugenics, where people looked at the mental capabilities of people and tried to select out those that they saw were inferior. And that led to what's known as social Darwinism. It led to women who were thought to be of lower intellect sterilized. It even led to Nazi Germany, the idea of the superior race and getting rid of people that didn't look like them. And we see social Darwinism coming up again and again sometimes, so we have to be careful about that. But we also need to understand that nature has selected to create, in a way, the body that you have and the brain that you have and the brain that humans have. And we live in a modern society, but our brain took a long time to modify and changed under very different pressures that we face today. And that can be good and that can be bad. Okay, that ends that lecture.